Welcome back to our class. Good morning. I'm Rohit. Today I want to share little about our first chapter, periodic table and electronic configuration. Now I want to discuss about how to write subshell electronic configuration, how to find period, group and block of the elements, and another things, that is how to find period, group, block and the characteristics of the S block elements. Now I want to discuss about that is in subshell electronic configuration, how to write it. That is a help of a principle, that is Aufbau principle. Everyone listen to me. Here I did show how to arrange electrons in a subshell. Here we can write 1s2, the first shell S subshell and the maximum electron present in 2. 2s2 means second shell S subshell, maximum electron present in 2. Here the second shell have 2 subshell, 2p6 second shell. Here 3s2 means third shell, first subshell have a maximum electron 2, another 3p6 means third shell, second subshell, that is p, maximum electron 6. Here 3d10, that is in third shell, D subshell, maximum electron 10. Aufbau principle says that the electron filling in the subshell in order to increase their energy, that is Aufbau principle. Once more, electron fillings in the subshell in order to increase their energy, that is Aufbau principle. Now we want to check about how to write subshell electronic configuration of the elements. Let me start how to write subshell electronic configuration. Here 1s2. This 1 means first shell. S means subshell. Subshell or block. 2 means maximum electron present in that subshell. I want to repeat that. 1s2 means 1 means the first shell and S means the subshell and 2 means maximum electron present in that subshell. Here I want to explain with one example, that is sodium. You know that sodium, the atomic number of sodium is 11. How to write subshell electronic configuration? We know that the 11 electrons are present here. Firstly, we can write 1s2, then 2s2, then 2p6. You just count how many electrons are configured here. 2 plus 2, 4 plus 6, 10. Then remaining 1 electron, 1s2, 2s2, 2p6 and remaining 1 electron present, that 3s1. Now I want to explain how to find period of that element, period. Here period means we can take the largest shell, that is period. Here 3 is the period of that. Next one, block. How to find block of this element? That is, you can take the outermost subshell, that is in S. Here the block is S. Now we want to check what is the group of this element. group of this element, that is, you can take the electron present in last subshell, that is a group here. 1 is the maximum electron present here, so we can take group as 1. I want to explain once more. Here we can find the period, block and group of this element, that is, here you can write in order to explain, that is already explained in above principle. Here we can 11 electrons are there, so in first shell 2 electron, 1 is 2, then second one 2 is 2, 2 is 6. So we can calculate 2 plus 2, that is 4 plus 6, 10. We here in 11 electrons are there, then last subshell, that is 3s1. Now I want to explain once more in period, that is in period means the largest shell. Here first shell, second, here also second, here third is the largest, so period we can take here 3. Then block we can take here in outermost subshell, that is our block, outermost subshell here present in S, that is block. Then group here we take the outermost subshell, the how many electrons are present. Here 1 electron are present, we can take group as 1. Here I want to share one more example, that is in magnesium. You know that the atomic number of magnesium, what is the atomic number? 12. Okay, how to write the subshell electronic configuration in the help of above principle? What do you mean by above principle? Above principle says that electron filling in the subshell in order to increase their energy. So here 12 electrons are there. We filling the first subshell, that is 1s2. The second one 2s2, here 4 electrons are configured or filled, then 2p6, you just calculate that 2 plus 2, 4 plus 6, 10 electrons are completed, remaining 2 electrons in 12, that is in 3s2. Here you just calculate that 2 plus 2, 4 plus 6, 10 plus 2, 12. Completed that subshell electronic configuration. Here I want to check the period of this element, that is, how can we identify the period? Here the largest shell, that is period, here 3 is the period. Okay, the second one, block of this element. What is the block? How can we take that? Here the last subshell, that is block, here also block is S, and the last one, group of this element. Group means we take the last subshell or largest subshell, number of electron present in this subshell, that is group. Here 2 is the number of electrons, so we can take the group number 2. Clear? Once more I want to explain, this is period is the largest shell, block is the outermost subshell, and group is the number of electron present in outermost subshell. I want to explain one more example, that is in calcium. You know that the atomic number of calcium, that is 20. 20. How to write the subshell electronic configuration? That is 1s2, 2s2, 2p6, 3s2, 3p6. I want to check that here. 4 plus 6, 10 plus 2, 12 plus 6, 18. We here in 20 protons are there. Then you know that 4s2. Okay. Now I want to check the period of this element. How can you calculate the period? The largest shell, that is 4, then block of this element, the outermost subshell, that is S, then group of this element, the number of electron present in outermost shell, that is here also 2. Okay, here we can discuss how to find period, group, block of the element. I think everyone got it. Now, I want to discuss about the peculiarities of S block elements. What is the peculiarities? Now I want to discuss some questions about in our chapter. We already learned about in S block elements here. When the S block elements react, do they donate or accept electron? You know that the last subshell failed 1 or 2. So here there is a possibility to donate the electron. What is the answer? Correct answer? To donate the electrons. Okay. The second one, which type of the chemical bond is usually formed? Which type of the chemical bond? You know that to donate electron or accept electron. This kind of chemical bond also known as ionic bond. Here the answer, ionic bond. Next, how many electrons are donated by the first group elements? How many electron donates in first group elements? You know that in first group elements donate only 1 electron. Here the correct answer, that is 1. Next one, what about the second group elements? You already understood that the second group elements also donate the 2 electrons. Now we want to fill the table, that is here first group indicate capital X and second group indicate capital Y. Here the valency, that is in valency in first group, you already know that studied about that 1, here group 2, 2. Here the oxidation state. What do you mean by oxidation state actually? The number of electrons donate or accept in the time of chemical reaction, that means, or sharing also, that means oxidation state. Here 1 electron is donate, so this element got plus 1. Plus 1 means 1 electron donate. Here increase 1 proton, plus means proton, 1 electron donate and here 1 proton is increased. So this plus charges indicate also the increment of proton also. Here the symbol of the ion. How to indicate symbol? Here X, here 1 electron is go out, so X plus. What is it? X plus. The chemical formula of oxide. Here we can discuss that when this X element react with oxygen, what is the valency of oxygen? That is 2. We can write the lower portion of the X, that is X2. Here the valency of X we can take 1. So X2O1, that is X2O. Clear? Here the second group, that is Y, valency 2. The oxidation state here 1 plus 1, here plus 2. The symbol of ions also indicating Y2 plus. What is the chemical formula? Anyone guess that? Okay, I will disclose that. Here Y have 2 valency, then Y also have 2 valency, both of have 2 valency, we can cancel to each other, or 2 by 2 we can get in both side 1. So YO, here we can get YO. I want to explain once more, that is Y have 2 valency and oxygen also have 2 valency. In this side we can write and here we can indicate a simplest form of that. Then we can cancel here 2 by 2 and 2 by 2 we can get 1. So that YO. This is our chemical formula. We already discussed about some characteristics of S block elements. We look at this more characteristics about S block elements. First one, it will shows very high electropositive or metallic character. The second one, it will shows very low non-metallic or electronegative character. It will shows very low ionization energy. And another characteristic, that is, it will include first and second group. That is the peculiarities of this block. We already discussed how to find period, group, block, and how to write subshell electronic configuration, and we already studied about the characteristics. Everyone, you just notice every points in your notebook and show me after the class. Thank you.